Okay, let's look at the behavior of the capacitor and the inductor when we apply some sort of voltage to either of these energy storing devices. So when we supply a voltage to our capacitor, and remember our conventional current flow is this way. However, let's just kind of look at electron flow for a moment. Remember, electron flow means that our electrons are actually flowing this way in the circuit. So what would happen is we're going to build up along the bottom plate these electrons, and along the top plate we're going to build up the opposing charges, the positive, until we get to a certain point in our circuit. Now, in this simple series circuit, whatever our voltage supply is, that's kind of what we're going to store over here on our capacitor plates. So here's a little analogy for you with our water pump shown below with a capacitor. So our water pump, this is like our voltage supply, and it's going to be pumping water into our circuit. Notice when we get to this this constricting point in the pipe, that flow is that's going to slow down the flow of the water. This is kind of like a resistor in our circuit. So that's going to control the speed with which our water flows through the circuit, or the flow rate of that water. And then the water will fill up this tank, which is a little bit like our capacitor is going to act in the DC circuit. And I've got this blocked off here, but at some point this tank is going to get full, and we're not going to be able to store any more water in the tank, and there'll be water through here as well. And once we get to the point where that tank is full, then there'll be no more water able to store, and therefore the flow of that water will stop. Okay, so at that point, when the tank is full, water stops flowing. Now, you'll see in a lot of circuits that a water tank is kind of like an analogy to a voltage source. And that's the same thing that's going on here, is our capacitor is kind of like a voltage source itself. So it's going to store that voltage or that potential that we could use for something else until we need it. Okay, so basically in steady state, once that capacitor is full, it's stored all the charge that it can store. In the bottom circuit, it's storing water. So once it holds as much water as it can hold from that circuit, the flow of the water stops, okay, and it just kind of sits there. And that's what we call steady state. It'll stay that way for a good bit of time. Now, let's say we block off the source, or we turn off the source. I'm going to kind of block it here. And then we open up, so to speak, a second pathway for that water. What will happen is that water will then flow through the new path. Again, here's another resistor, so we're going to restrict the flow rate of that water, and then eventually it just kind of runs out. Okay, so water everywhere, or whatever, you know, we might control where that goes, but that's kind of like the discharge phase of our capacitor. Okay, so basically we cut off the supply and we allow that water to leave the tank. Now if we cut off, whoops, I think I erased my circuit here. If we cut off the path of that water flowing out, and then we allow connection back to the source again, the tank will then, of course, fill up again. And that's kind of what a capacitor does. It'll fill up the with voltage, and it'll hold that voltage. And then when we use it, it will discharge, or we empty the tank, so to speak, and then we'll charge it back up. Okay, so that's kind of how our capacitor works in our circuit. Now, for the inductor, something similar is happening, except if you imagine our current flowing into our coil, and you can kind of see the current flowing through the coil. Notice it's going to take some time to get through that coil, okay? So initially, there's no current flowing through our circuit until we get over this momentum, and that kind of looks a little bit like a water wheel. So if you imagine that this water wheel is our inductor, and of course we have another resistor here that's going to control the flow of the water initially. So as our water flows through the resistor, it's going to slow down, it's going to control the flow rate, and then it gets to this water wheel. If you know how a water wheel works, initially that water is just going to start kind of piling up here until it overcomes the inertia and starts turning that water wheel. Once it starts turning, it'll start turning slowly at first, and then after a while, it's just going to be turning enough to let all of the water flow through the circuit and back to the pump. Okay. So it's really not storing current so much as this turning motion just kind of keeps pushing the water through. And then once I open up another path for that, it's going to continue to push that water through. Okay, so with that motion until it stops. Okay, so the water wheel is not a fantastic analogy. Most analogies fall apart at some point, but kind of gives you an idea of a visual, if you will, about how that inductor works. So once we reach steady state, what we call steady state, in DC, that means for the capacitor, tank is full, or it's no longer charging, and there's no current flowing in the circuit. For the inductor, steady state means that the wheel is turning at whatever pace it needs to keep the current going. And so at that point, you don't have any opposition to that current, so your voltage is 0. Okay, so there is a voltage across the cap, but no current. For the inductor, there's no voltage, but there is current. So those are kind of the complement to each other. And next we'll talk about what each of these does in the initial phase, okay, and not steady state.